Okay. The plane is flying towards a circular cloud of volcanic ash as shown in the diagram. C is located 53 kilometers east and 96 kilometers north of the plane's current position. Okay, so if I was to draw a triangle on this, okay, which I'm doing now, the plane's current position is located here. Okay, and it's technically the position. It's technically the position 53 across and 96 up. It is the point 53, 96. Okay. Plane is at 0, 0 because we're using this as the origin because relative to the plane it's 53 across, 96 up. Find the slope. The plane's current path is cos inverse, or basically, if I was to map out the plane's current path, it looks something like this. Cos inverse means, remember SOHCAHTOA. Ka means CAH, okay? Adjacent over hypotenuse, which is 5 over 13. Now, I told you earlier that do Pythagoras' theorem here. You're going to get 13 squared equals, we'll call it y squared. 5 squared plus y squared. 13 squared therefore is equal to 169 equals 25 plus y squared. This means that 144, when you take away the 25, equals y squared, y equals 12. Now, I would have told you yesterday that the slope is the same thing as tan. It's rise over run. You're rising up 12 and you're running across 5. That is the slope of your line. Okay? Now what we can do next is, this full chapter, once again, this full exercise is about one equation. It's about the point D equals AX1, or the equation BY1 plus C, all over A squared plus B squared. Now what we can do is this, guys. Find the equation of the plane's path. Well, what we know about the plane's path is its slope is 12 over 5 and it contains the point 0, 0. So what we can do here is we can find the equation of the line for the plane. So what we do here is y minus y1 equals m into x minus x1. What we then do is y minus 0 equals 12 over 5 into x minus 0. Then what we can do is we can say that y equals 12 over 5x. That is the same thing as 5y equals 12x. Bring the 5y over the other side and we'll get is 12x minus 5y equals 0. Let's turn this into a, b and c. What's the a value? The b value? The c value? 0. Okay, shh, excuse me. Okay, calculate the shortest distance between the plane and the centre of the ash cloud. The centre of the ash cloud is located at 53.96. So x1, y1 is 53 and 96.
Did you already do that? You found that?
No, we haven't done it yet. We just got the equation of the line, Simon.
But we already found it when we did Pythagoras, not 13 squared. It's 169.
No, we haven't, because it keeps continuing. It's just its speed, not its distance. So you're given the equation of a line, Simon, and you have to find out how close this line goes to the centre of the ash cloud. That's what we're doing here. Okay, so we have the equation of the line, which is this here. And now it's the same question what we do before. It's the centre of the ash cloud, x1, y1.
But if you're taking the top of that triangle as...
The next part is the following, okay? You enter, if somebody can look at the back of the book even just for the distance, that'd be perfect for me, okay? You're going to enter all of this information into your D formula. And once you find out what D is, can I tell you what D is going to be?
12.
What? 12 kilometers, perfect. Now guys, here's the tricky part, alright? What they're saying is, find how much distance you travelled with the ash cloud. So look at this. The ash cloud is a circle, like so. Your plane travelled, bam, through here. It made a chord. Your your center of the cloud is here. What you can do next is you make an isosceles triangle, because the radius is 20. 20, 20. You then use this as the number 12, because you're told that it travels a distance 12 away from the center. Use Pythagoras' theorem. Find out the value of x. Then double that value to find out how much distance you actually travel through the cloud. Is that alright? Yeah. That's your end of that question. Okay.